On the 14th of December 1972, when humanity last set foot on the moon during the Apollo 17 mission, an astronaut looked back at Earth and softly said, "How beautiful this planet is, and how lonely too." And today, more than 50 years later, we are going back. But this time, not just to the moon, but toward our future. But the real question is Earth still the same as it was during the time of Apollo 17? Or have we changed our home so much that it is no longer recognizable? And if Earth has truly changed, are we even worthy of returning? In today's video, we will decode this exact thought. How did Earth change so dramatically from 1972 to 2026? And the biggest question, are the reasons behind this truly justified? Or are we heading toward an unknown future that could be more terrifying than we can ever imagine? Apollo 17 and the blue marble. It all starts on the 7th of December, 1972, when Apollo 17 launched. Back then, perhaps no one realized that this wasn't just a mission. It was going to be humanity's last footprint on the moon. There were 3 astronauts on this mission: Eugene Cernan, Harrison Schmitt, and Ronald Evans. But one of these names stood out, Harrison Schmitt, because he wasn't just an astronaut, he was a geologist. Meaning, for the first time, someone went to the moon not just to explore, but to understand our universe. And this is where the purpose of the mission changes. Because they spent more than 3 days on the lunar surface, collected 110 kilograms of lunar rocks, and performed multiple experiments: soil analysis, seismic activity, radiation study. Meaning, this wasn't just a visit, it was a detailed, scientific investigation of the moon. But amidst all this, a moment occurred that almost vanished from history, when they looked at Earth from space and took a photo. This wasn't just any normal photo. This was the blue marble, an image that is considered the most famous and iconic picture of Earth to this day. And in that photo, there were no borders, no countries, just a small blue planet, floating all alone in the infinite darkness of space. When Apollo 17 looked at Earth from space, the image that appeared was quite different from today's planet, because back then, Earth looked cleaner, more raw, and more natural. The population was comparatively very low. Ice caps were larger and more stable. The forest cover was thicker, and at that time, the entire global population was just 4 billion, meaning there was less pressure, and nature was more dominant. But the strangest difference was in Earth's color. Deep blue oceans, bright white clouds, clear land contrasts. Everything was so vibrant, as if someone had just turned up the saturation level. But in reality, there was no filter, because back then, imaging was completely raw. No heavy processing, no artificial color correction. What they saw was exactly reality. And because of that, this image wasn't just a photo. It was a snapshot of a pure, untouched Earth. A planet that looked much more alive and balanced compared to today. The Earth today, 2026. But Earth is not the same today. The planet that looked so calm, balanced, and untouched from space 50 years ago has completely transformed today. And the first major change was brought by the population explosion. In 1972, the population was 4 billion. But today, we have crossed 8 billion, meaning double the people, double the demand, and double the pressure on Earth. Then comes industrialization. Factories, cities, transport. Everything is at its peak, and development happened incredibly fast, but its cost has been just as heavy. And here enters climate change. This isn't just a theory anymore. It is now reality. There are scientifically proven changes. The Arctic ice is shrinking. Forest loss is happening rapidly. Pollution in the oceans is increasing, and global temperatures are continuously rising, meaning Earth is slowly losing its balance. But there is another side to this story, and that is, over all this time, our power of observation has also evolved. In 1972, there were limited satellites, low-resolution images, and a basic understanding. But today, we have high-resolution satellites, real-time Earth monitoring, and AI-based climate tracking. Organizations like NASA and other global space agencies are continuously scanning the Earth. Now, we don't just look at Earth. We measure it, predict it, and deeply analyze it. But if you carefully look at the Earth's image from 1972 and 2026, you will understand a massive difference, and that difference is in color. The story behind this is also quite interesting and dangerous, and I will talk about it in just a little bit. Why did we stop going to the moon? But right now, let's move to a very big, controversial question that people often ask. Why were the moon missions stopped after Apollo 17? Was something being hidden, or did the interest simply fade away? Look, the reality behind this isn't dramatic, it's purely practical. Because the first reason was the cost. NASA's Apollo missions were so expensive that billions of dollars were being spent on every single mission. And when a country has already reached the moon, justifying the next mission becomes very difficult. And that brings us to the second reason: political interest. The main goal of the Apollo missions wasn't just science, it was also about showing dominance in the Cold War. Because there was a massive race between the USA and the USSR about who would reach the moon first. But as soon as the US achieved the moon landing, it effectively won the space race. And slowly, the pressure of the Cold War started to decrease. And when there was no urgency, the competition slowed down, the funding and focus shifted, and public interest also dropped. Because the first landing was historic, the second landing was exciting. But when the same things started repeating, it became normal for people. And when the public's excitement began to fade, the government stopped pushing as hard. And the result of all this was that the moon missions slowly came to an end. There was no secret shutdown behind this, no hidden conspiracy, just a simple reality that once a goal is achieved, spending that much money and energy on it is no longer justified. The Artemis generation. But here is an interesting twist. We stopped, but not permanently. And that brings us to the present, where the story begins again, but this time with a much bigger version, Artemis II. This mission is not just taking humanity to the moon, it is taking us beyond the moon, toward the future. Because its goal isn't simple, it's strategic. Humans will be sent to the lunar orbit. Human survival in deep space will be tested. Systems will be checked that are critical for future missions. Meaning, this won't be a landing. The astronauts will not land on the moon, and this is exactly the preparation for the future. The selected astronauts for this mission are Reed Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen. Meaning, this isn't just a US mission, it is a global collaboration. Now, another doubt is running through people's minds after watching some videos. Were these astronauts actually inside that rocket? Or are we just being fooled? What is the truth? And what is a myth? Understanding this isn't that simple. And if you want to clear up all these doubts and questions, I have made a detailed video on this topic. You can go watch it. For now, let's get back to our main topic, the most important part. What is different from Apollo 17? Look, Apollo was short-term exploration, a mission to win a race. But Artemis is a long-term human presence plan. It's about building a sustainable future. During Apollo's time, there was basic technology and limited computing power. But in the era of Artemis, that is not the case. Today, we have advanced AI, automation, and reusable systems. During Apollo, none of this existed. There was the pressure of the Cold War. But Artemis is global teamwork. Meaning, before, we went to the moon to prove that we could go. But now, we are going back to stay. The true colors of Earth. If you look at today's image from Artemis II, one thing is immediately noticeable. The Earth looks a little dull, muted, and less vibrant. And this raises a question: have Earth's colors changed? The answer is yes and no. Because what has actually changed is the way we look at it. And there are three main reasons for this: advanced sensors and true colors. Today's cameras and sensors are so advanced that they capture light exactly as it actually exists, avoiding overexposure. In the Apollo era, while capturing bright objects, the image would get a bit overexposed, making the colors look more vibrant. But today, exposure is carefully controlled, so no details are lost. Realistic post-processing. Today, images are edited, but the goal is to maintain accuracy, not extreme saturation or dramatic contrast. The photos from Apollo 17 were beautiful, but today's Artemis II images are accurate. That is why, sometimes, things that are more real don't look quite as perfect. What we learned: if you compare the time of Apollo 17 to today, the biggest difference can be understood in just one word: evolution. The level of technology has changed so much that the two eras feel like entirely different worlds. And now, the question isn't what Apollo 17 was. The question is, what did it teach us? Because real power doesn't lie in the missions, it lies in the lessons. Apollo 17 clearly showed for the first time the limits of human endurance. Living in space, low gravity, isolation, all these have a direct effect on the body and mind. The astronauts showed how long the human body can handle extreme conditions and when it starts to break, because the moon's surface is not smooth. It is dusty, sharp, and unpredictable. Movements are different. Equipment can easily freeze. Meaning, the moon is not as simple as it looks. And that is why the Apollo missions weren't perfect. Some tools failed, Some systems didn't work as expected, but those very failures became the foundation for future improvements. Outside Earth's protective atmosphere, radiation is a real threat. For long-term missions, this is one of the most dangerous challenges. And now, Artemis II is using all these lessons to build better suits, better radiation protection and safety, and better planning and backups. Meaning, Apollo taught us what could go wrong, and Artemis is ensuring that those mistakes are never repeated. The ultimate goal, Mars. But the real goal of Artemis II isn't the moon. It is Mars. Yes, the moon isn't just a destination, it's a testing ground, a place where we are practicing for the future. Because going to Mars isn't just a mission, it is the most complex challenge in human history. That is why everything will be tested on the moon first. Astronauts will have to survive for months in isolation with limited resources. Structures will be built on the moon where humans can live safely, meaning it won't be a temporary visit. There will be full preparation to stay, extracting water, ice, guaranteeing oxygen, and producing fuel. Meaning, instead of relying on Earth, we will have to learn to survive entirely in space. And all of this is critical for Mars. Because on a Mars mission, returning won't be easy, and carrying everything from Earth won't be possible. Therefore, the moon is a bridge between Earth and Mars, a training ground. And only when we learn to survive on the moon will we confidently be able to say, now we are ready for Mars. In the 70s, humanity looked at Earth from the moon and realized, this is our home. And in the 2020s, we are going back. But this time, not just to look, but to understand and protect it. Because the truth is, space exploration isn't just for the moon or Mars, it is for Earth. And maybe the next time an astronaut looks back, they won't think that this planet is lonely. Instead, they will think that this planet is incredibly valuable. Now, I have a very special and important video for you about Mars. If you want to know whether life is truly possible there, and if humans will ever be able to live there in the future, then definitely click here and watch this video. Perhaps what you see there will completely change your perspective. I will see you there.